Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at Lambda, and this is the serverless section of the course. This is the very last hands-on section. And in this section, we're going to just learn the theory of Lambda, then we're going to go ahead and create a serverless website using API Gateway as well as Lambda. And then in the next lecture, we're going to create a skill. We're going to create an Alexa skill. And most people don't realize this, but every time you talk to Alexa, you are talking to Lambda. You are talking to the cloud. And when Alexa responds back to you, that is the cloud talking back to you. So before we go on to what Lambda is, let's talk a bit about the brief history of cloud. So we used to always have data centers, and basically all organizations would have their own data centers. Some would use, providers like Rackspace, for example, and it would all be physical hardware. So when you ordered a server, like a web server, let's say, that would actually be a physical server dedicated to you. I used to work in the cloud when this was the case, and sometimes it would take 10 days to provision a physical server. Some companies I work for, it takes 6 months. So when you went in and you ordered it and say you wanted 2 web servers, 2 database servers, a load balancer, some firewalls, and then some SAN, that could take anywhere from 10 days to 6 months to provision. And then Amazon came in and launched EC2 in 2006, and suddenly you could provision virtual machines just using a simple API call. You could have a machine with you ready in minutes, and it completely changed the entire architecture, completely changed the entire game. And public clouds started becoming bigger and bigger. Rackspace and Amazon went to war with each other, but Amazon could basically completely outspend Rackspace, on investment. And then I basically moved around the UK cloud industry, so I left Rackspace and went to work for a whole bunch of other cloud providers. And it's when I actually saw CloudFormation that I started realizing how powerful AWS's cloud was and how infrastructure was being turned into code. So basically, EC2 was launched in 2006. That was infrastructure as a service. We then moved on to platform as a service. This was Microsoft are really big in this space. And then Amazon launched things like Elastic Beanstalk, for example. It's a good platform as a service example. So this is where you upload your code, and essentially what will happen is the public cloud provider will provision all the infrastructure underneath. You don't need to worry about that. Then containers started really taking off in about 2014. So Docker, for example. We didn't really cover containers in this course. They don't really come up in the Solutions Architect exam. They do come up in the Developer and SysOps Administrator Associate exam. And then basically containers moved on even further, and we went to serverless. And with serverless, literally all you worry about is your code. You put your code up into AWS or into the cloud, and then someone will go and do something. So it might be uploading a file to S3, or it might be just a request from API Gateway, but something will go in and trigger that code, and you're only paying for the execution time. So you're only paying for when that code is being executed. And that's really the full evolution of cloud. We've gone from physical servers inside data centers, and we're up to almost the ultimate abstraction layer now, which is just focusing on your code and not having to worry about anything else underneath it. With containers, you still have to worry about managing the containers. And you get things like Kubernetes, for example, that do that at scale. But with serverless, you don't need to worry about managing anything. All you need to worry about is your code. So that brings us on to Lambda. And what is Lambda? Well, Lambda is the ultimate extraction layer. So you've got your data centers. Inside your data centers, you've got your hardware. Inside your hardware, you've got your assembly code and protocols. You've then got your high-level languages. You've then got your operating systems that you're running. You've then got your application layers as well as AWS's APIs. And sitting on top of all of that, or extracted away, is AWS Lambda. So basically, AWS handle all of these things for you. All you need to worry about is your code. So AWS Lambda is a compute service where you can upload your code and create Lambda functions. And AWS Lambda takes care of provisioning and managing the servers that you use to run the code. You don't have to worry about operating systems, patching, scaling, etc., etc. All you do is worry about your code. And you could use Lambda in the following ways. So you can use it as an event-driven compute service where AWS Lambda runs your code in response to events. And these events could be changes to data in an Amazon S3 bucket or a DynamoDB table, etc. And those event-driven compute services are called triggers. And then you can also use it as a compute service to run your code in response to HTTP requests using Amazon's API gateway or API calls made using the AWS SDKs. And this is what we use it for at A Cloud Guru. We actually use it in both of those ways, actually. When you upload a video to our site using S3, that will then trigger an Elastic transcoder job. So we use it both as an event-driven compute service as well as a compute service that runs in response to HTTP requests that are hitting API gateway. And we'll cover that off in a couple of slides. So what is Lambda? Well, let's say we've got our user. Here's our user, and they want to create a meme. So they then upload this meme to an S3 bucket, and that triggers a Lambda function. And the Lambda function essentially will take that meme, and it will basically take the metadata as well, and it will put the words "why," for example, over the meme. So that would be how it creates a meme. And the cool thing about Lambda is it can trigger other Lambda functions. So it can trigger another Lambda function to tell the user that here you go, here's your meme. And it could also trigger another Lambda function to store that meme back in an S3 bucket. And then you could use cross-region replication to store that meme somewhere else in the world. The other way Lambda works is as a compute function. So we've got our user, they send a HTTP request to API gateway. API gateway then proxies that to Lambda. Lambda will run the code in response to that HTTP request and then send it back to API gateway. It will send it back to our user. And the cool thing about the way Lambda scales is, let's say we've got two users with two separate HTTP requests. Both will hit API gateway and both will trigger to the same Lambda function, but it will be separately run. So they'll be separately isolated from each other. And of course, they'll return a response back to the user. So Lambda it's bit different from auto-scaling in that, obviously when a user goes in, you might just spread it across two web servers. If you have 1 million users hitting your API gateway at once, that will then go on and trigger 1 million different Lambda functions. So that's how well it scales. And we really need to talk about traditional architecture versus serverless architecture, because this comes up an awful lot in the Certified Solutions Architect Associate exam. So traditional architecture in cloud has always been your user sends a request, it hits Route 53, let's say, and then goes on to your Elastic load balancer. Your load balancer sends that on to your web servers, and then your web servers might communicate with a backend RDS or database server, and then it sends back a response to the user. Now, that's all well and good, but you're still relying on you're still relying on virtual machines, you're still relying on operating systems. Now, the cool thing about the serverless architecture world is that basically you send a response to API gateway, that then sends a response to Lambda, and that can write to DynamoDB, it could write to Amazon's Aurora or serverless Aurora, and then it will send the response back to the user. But like I said, if you get 1 million users hitting API gateway at once, and assuming you haven't throttled API gateway, it will scale to that instantly. You don't need to worry about auto scaling or your EC2 instances becoming overwhelmed. So serverless architecture is a much better way of architecting your products. And in the exam, you're going to be asked to create you'll have all these different scenario questions. And essentially what they're testing you on is how well do you understand serverless architecture. And so just remember that you're always going to have API gateway at the front end to serve the request. You're going to have your Lambda functions that scale out automatically. And then you're going to have if you're going to go serverless, you want a database that's serverless. So it'll either be DynamoDB or it could be Aurora serverless as well. So what languages does Lambda support? Well, it supports Node.js, Java, Python, C#, it supports Go, and it also supports PowerShell. And in terms of how Lambda is priced, it's priced on two different things. So it's priced on the number of requests. So the first 1 million requests are free, and then you only are paying 20 cents per 1 million requests thereafter. We at A Cloud Guru, I think we grew to like 300,000 students before we even started getting a Lambda bill. So it is amazingly cheap. It really allows startups to scale very, very quickly. Even now, we're getting close to 1 million users, and our Lambda compute bill, I think per month, is about $400. If we were actually doing the same level of compute across EC2, we'd probably be spending upwards of $100,000 per month. So that's how much Lambda has saved our company, and that's why you should really look at going serverless. And then you also build on duration. So however long your function runs, we'll basically bill it. So let's say your function runs for 100 milliseconds, then you're going to be charged a certain amount. If it goes for 200 milliseconds or a minute or 10 minutes, then you're going to be charged more and more. So you're charged on the number of requests and then the duration of the requests. So why is Lambda cool? Well, you don't have to worry about any servers. You don't need system administrators anymore. You don't need to worry about patching your operating system. You don't need to worry about antivirus. You don't need to worry about why your EC2 instance keeps crashing. You don't have to worry about servers at all. It continuously scales. Like I said, every time you make an invocation to API gateway, that will trigger a separate Lambda function. And it's super, super cheap. Like I said, we spend $400 a month on our compute bill when really it should probably be in the regions of 100,000 or so. So Lambda is seriously cool. And like I said, every time you deal with Alexa, so every time you speak to an Amazon Echo or to a Echo Show or an Echo Dot or whatever, you are actually directly speaking to Lambda. So it is really cool when you think about it. You are speaking directly to the AWS cloud, and the AWS cloud is speaking back to you. So onto my exam tips. Just remember that Lambda scales out, not up automatically. So if you have 5 invocations, that's going to scale. It's going to scale out to 5 different Lambda functions being executed at the same time. Remember that Lambda functions are independent, so one event equals one function. Remember that Lambda is serverless, and you should really go into your exam understanding what services are serverless. So RDS is not serverless. It's even though you don't have to worry about the operating system, Amazon takes care of it. There is still an operating system there that they have to go in and patch, and you still have downtime whenever they're doing maintenance and stuff. The exception to that obviously is Aurora Serverless. That's the only RDS service that is serverless. Things like DynamoDB, things like S3, things like Lambda, API Gateway, all serverless technologies. EC2 obviously is not serverless. It's a virtual machine. And then just remember that Lambda functions can trigger other Lambda functions. So one event can actually equal X number of functions if functions are triggering other functions. So you could have one event which triggers off 5 or 10 or 15 or 20 different Lambda functions. And then just remember that architectures can start getting extremely complicated with Lambda, and it can be really difficult to debug these. And that's what the AWS X-Ray service allows you to do. It allows you to go in and debug what is happening with Lambda. We're not going to have a lecture on X-Ray because literally all you need to know is what it is. So it helps you debug your serverless, your serverless applications. And then Lambda can also do things globally. So you can use it to back up an S3 bucket to another S3 bucket, etc., etc. And go in knowing your triggers. And we're going to cover this off when we go in and build our serverless website, when we go in and build our Alexa skills, but you really need to know the different Lambda triggers. You need to commit them to memory, or at least you should know what can't trigger Lambda. For example, RDS cannot trigger Lambda as of yet. So that is it for this lecture, everyone. If you've got any questions, please let me know. If not, feel free to move on to the next lecture where we're going to go in and create our first serverless website using API Gateway and Lambda.